Welcome back to Applied Mathematics. In this video, we're going to be multiplying polynomials. And the process of multiplying larger polynomials looks very similar to the process of multiplying by a monomial, just a little bit more involved. Let me get my head out of the way and let's dive right in. Something relatively simple, a binomial. Polynomial with two terms like 2x plus 7. Times another binomial, a polynomial with two terms, like 3x minus 5. The technically correct way of working through this is to treat 2x plus 7 as a single entity, let's highlight it over here instead, and then distribute that single entity across everything in the other polynomial. So we will have 3x times 2x plus 7 minus 5 times 2x plus 7. Now, if we look here, we are multiplying a polynomial by a monomial. If we look here, we are multiplying a different polynomial by a monomial. We do have to be a little bit careful here to make sure that that negative gets distributed along with the 5. But other than that, everything is going to work the way you think it will. 3x times 2x is 6x. 3x times 7 is 21x. Minus 5 times 2x is minus 10x. Minus 5 times 7 is minus 35. Then we have a couple of like terms that can be combined. The 6x squared in front stays a 6x squared in front. Then we have positive 21x and negative 10x, which all told is positive 11x. And then we have our minus 35. All right, so it is the distributive property, followed by the distributive property twice more. There's technically nothing new here. I do want to mention, you may remember from a previous mathematics course a mnemonic called FOIL, which helps you remember how to do this so that you can go from this first step to the last step without having to write out all of the stuff in between. I don't quite like the mnemonic device FOIL because it is a special case for dealing with binomials, and we're going to be dealing with some more complicated things. But the process does work, so if you remember it from a previous course, you're welcome to use it. There's nothing wrong with it. But distributing, you can think about it term by term. Take the first term here, 2x, and distribute by multiplying by 3x and by negative 5. Then take the second term, the 7, multiply by 3x, multiply by negative 5. You get 2x times 3x is 6x squared. 2x times minus 5 is minus 10x. 7 times 3x is 21x. 7 times minus 5 is minus 35. Things show up in a slightly different order than what I wrote down, but it's the same things, and that's all that matters because it's addition, and addition has the commutative property. With that in mind, let me get my head out of the way, and let's dive right into the next example. (3x plus 4y times 2x plus 5y). The distributive property, multiply the first thing, 3x, times everything in the second polynomial. 3x times 2x is 6x squared. 3x times 5y is 15xy. Then, take your second term, our 4y in this case, multiply it by everything. 4y times 2x is 8xy. 4y times 5y is 20y squared. Then look for some like terms to combine. We do in fact have two like terms here. 15xy plus 8xy is 23xy, giving us a final result of 6x squared plus 23xy plus 20y squared. if we have more terms, the process doesn't change. If I have something like 2x minus 7 times x squared plus 5x plus 4, I'm still going to do the same thing, although this time I'm going to write things out just a little bit differently. I'm going to take my 2x and I'm going to distribute it. 2x times x squared is 2x cubed. 2x times 5x is 10x squared, and 2x times 4 is 8x. Then I'm going to take my second term, but instead of continuing on the same line, I'm going to go down to the next line, and I'm going to move over one space to multiply negative 7 times x squared, which is negative 7x squared. Negative 7 times 5x, which is minus 35x, and negative 7 times 4, which is minus 28. And the reason that I do this is if you look at what I've just written out, column by column, all of my like terms have naturally lined up with each other. So writing everything across one row does still work, but by writing it out in two columns like this, you save yourself some headache. And as we look at bigger and more complicated expressions, that becomes more important. All right, but we've got 2x cubed. We've got plus 10 minus 7, which all told is plus 3x squared. We've got plus 8 minus 35, which all told is minus 27x, and then we've got minus 28. If I do this multiplying something with 3 terms times something else with 3 terms, the same process still works, only things get a little bit longer still. So if I have something like x squared plus 2x plus 3 times 5x squared minus 7x plus 9, I can still use the same process. Start by distributing x squared. X squared times 5x squared is 5x to the 4th. X squared times minus 7x is minus 7x cubed. X squared times 9 is 9x squared. Move down to the second row, move in one space. 2x times 5x squared is 10x cubed. 2x times minus 7x is minus 14x squared, and 2x times 9 is 18x. Then my next term, which is this 3, move in one more space. 3 times 5x squared is 15x squared. 3 times minus 7x is minus 21x, and 3 times 9 is 27. Add all 3 of these rows together. Notice again that all of my like terms have lined up, and I get 5x to the 4th plus 3x cubed. Let's see, 9 minus 14 plus 15 is 10x squared. 18 minus 21 is minus 3x, and then 27 as our constant term. Things can get a little bit messy here when you have missing terms. So if you have something like x squared minus 9 times x cubed plus 5x, notice that I don't have the whole expression, right? If I was writing this out a polynomial, after an x squared term, I would expect to have an x term. Well, I can always multiply by 0, which makes that 0, and then adding 0 to something doesn't change it. So if I fill in the missing term and call that x squared plus 0x minus 9, then I haven't changed anything. And likewise, if I make this other one x cubed plus 0x squared plus 5x plus 0, then I haven't changed anything there either. But that makes sure that I'm not missing terms in the middle. And that's important because without those terms, my like terms would not line up. And it doesn't really make things that much harder. X squared times x cubed is x to the 5th. Then we're going to have 0 times x to the 4th. We're going to have 5x cubed, and we're going to have 0x squared. We're going to have 0x to the 4th. We're going to have 0x cubed. We're going to have 0x squared, and we're going to have 0x. Multiplying by 0 is easy. Then we're going to have minus 9x cubed. We're going to have 0x squared. We're going to have minus 45x, and we're going to have 0. So that's x to the 5th plus 0x to the 4th minus 4x cubed plus 0x squared minus 45x plus 0, which we can condense and just call x to the 5th minus 4x cubed minus 45x. Right. Did we gain anything by filling in those empty steps and filling in a whole bunch of zeros in this? Well, that depends. You may find that it's easier when you have the missing terms like this to just multiply everything across in a row, look for your like terms, combine them, and call it a day. You may find that it's easier to write everything out long form like this and just deal with the fact that there's a bunch of zeros. It's entirely whatever makes life easier for you. What I do personally is kind of a hybrid. I mentally fill in all of those zeros, and I use that to my advantage, and I just skip spaces as I'm filling this out. It works for me. It requires a little bit more thought and a little bit more foreknowledge of what's going to be happening, but with practice, you can get there too. The last thing that I want to look at in this video is what happens when you try to combine addition with exponents, x plus 5 squared. I said in the video where we talked about exponents that this does not work nicely and you have to do some process to get there. The process is to remember that something squared means that thing times itself. So x plus 5 squared means x plus 5 times x plus 5, and then we can multiply that out using the process we've been talking about in this video. X squared plus 5x plus 5x plus 25, which comes out as x squared plus 10x plus 25. We can also do that with higher powers, right? If I have 2x plus 3 cubed, that's 2x plus 3 times 2x plus 3 times 2x plus 3. And multiplying three things at once doesn't actually work. So we're going to have to multiply the first two of these things together, which is going to be 4x squared plus 6x plus another 6x plus 9. And combining some like terms there, 4x squared plus 12x plus 9. And then multiplying that out, we're going to have 8x cubed plus 12x squared plus 24x squared plus 36x plus 18x plus 27, which all told is going to be 8x cubed plus 36x squared plus 54x plus 27. I can't really say it's hard, but it's not simple either. I can't do these in my head. I don't expect that you can do them in your head. You have to write them out. There's not really much of another way about it. I will mention that you can do this in general, and some people like to try to memorize the formula for a plus b squared or a plus b cubed. If that makes you happy, you're welcome to do that. I personally find that memorizing a formula is terrible advice, and multiplying everything out by hand is actually easier, but your mileage may vary. In any event, that's all I have for you in this video, so as always, thank you for joining me. I'll see you next time.